So here's a lab in a lorry. Come in and I'll show you around. Well, we'll have a group of about 20 school children arrive, and we'll divide them up into three smaller groups, and there are 3 different experiments, and during the course of about 50 minutes they'll get to try 2 of them. So the first one we've got here, this green gunge is meant to be like oil, so what they're going to look at is how oil is sort of mined out from the ground by playing around with green gunge and wearing nice lab coats. So then coming through here, this experiment is about resonance, and how if you hit things at a particular frequency then they start oscillating. So they're going to be playing around with a wine glass and a strobe light, and then at the end watching a video of how a bridge in America many years ago collapsed because the wind started hitting it at the wrong frequency. And then right down on the end is the experiment I'm doing, which is looking at how light behaves, and in particular trying to understand why the sky is blue and why sunsets are red. So basically, actually, what we've got is these tubes of water, and we're going to stick in Dettol, which acts like the molecules in the Earth's atmosphere. And so we're going to shine a light up through our column of water with Dettol in it. And what's going to happen is the light's going to get scattered, so this looks blue at the bottom, and we get a nice red blob shining up on the ceiling at the top. And then we're going to go play around with these polarized filters to see how you can sort of block light out by rotating these around. So I think it's 2 things. One's to give school kids a sort of opportunity to come in and play with experiments and see how real physicists work, and then for them also to see what real physicists look like. So,
and is that you?
Well, that's another question. Well, actually, one of the other helpers this morning was a female engineer, and she says that often she'll come along and say she's an engineer and get the reaction, I didn't know girls could be engineers. So it seems that they do have sort of very fixed ideas of what scientists and engineers look like. There's a scheme called Science and Engineering Ambassadors, which aims to sort of get physicists and other scientists out into the community doing things like this, and so they occasionally advertise for volunteers to do things. And I saw an advert for it last year and I thought, oh, sounds a bit scary but it might be fun, so I did it once last year and enjoyed it, so here I am again. I actually enjoy it. It's a nice break from my equations on my computer.
Do you get nervous?
With this sort of thing, yes, because I don't have that much experience of sort of. It's one thing standing in front of hundreds of people and you're the focus of their attention, but when you've got to entertain 6 or 7 teenagers, it's, a bit more nerve-wracking. And then they can ask questions that are actually harder to answer because you don't know where to start properly, as in sort of physics questions. You know where the person's coming from and you can get quite technical.
Interesting. Hi guys, welcome.
Move right the way round. Okay. Close this curtain behind you. Right. Okay, so what we're going to be doing here for the next 20 minutes or so is looking at light and how light behaves and how we can explain some everyday things due to the physics of light. So what colour is the sky outside today? It's a nice day. Blue. Blue. Any idea why it's blue? Yes. Anyone? Sometimes people say it's because the sea is blue and the sky reflects the sea, but that's not it. We haven't got any sea around here. So what we've got in here, and this was being a bit temperamental earlier, but hopefully it'll be working now, is the thing in here is just a little bulb from a torch. So it's shining white light up at the ceiling. At least it should be if I can turn the lights. And what I've got here is just a tube full of water. Nothing funny going on so far. And I pop my tube of water on top of the white light, and so we've got the white light comes out here, goes straight through the water and up onto the ceiling. So what I've got here is a bottle of Dettol, so that's just the stuff that people use for cleaning their houses. So can I have a volunteer to pop some Dettol in for me?
I'll do it.
Okay, here you go. So if you squeeze up just about that much into the end of your syringe, and then pop it in the top there. Yeah, that's good. So if everyone has a look, yeah, thanks. So what colour does this look? If I give one of you a prism, this usually works easier. So try sort of rotating it around in different directions. Oh, there you go, back a bit. So what the prism's doing, we've got white light coming up, and the white light is actually made up of all the colours of the rainbow. The blue light, is made of waves like this, is hitting the Dettol molecules and getting scattered. So we're getting the blue light coming out of the side and the red light carrying up to the ceiling. So the light's coming from the sun and the blue light is getting scattered all over the place so that's exactly right as to why the sky's blue. So any ideas about why the sunset is red though? The Earth is surrounded by a thin layer of air and gases and things, and that's the atmosphere. And so the atmosphere's got gas in it, it's got nitrogen, it's got oxygen. Middle of the day, the sun's up there, End of the day, sun's down there, so the light's shining towards us like that. Okay, well, let's try something different now. So let's put the Dettol aside. So have a look at the tube through your bits of plastic, and I'll turn the lights down because that'll probably make things easier. So no, you're definitely not seeing things. So different people will be seeing different colours in different places probably, but you should be seeing some of the colours of the rainbow at least. And when this comes on, have a look at the screen through your bits of plastic and move your plastic around.
It looks like it goes off.
It does, it does. So you see it nice and bright, and as you turn your plastic round,
it goes dark.
So if instead though we thread our wave through there, what directions can you wiggle your wire in?
That one.
Up and down. So this with its long slits is forcing the wave to only go up and down and not side to side. Well, it's mixing. It's hitting one of these, and then what happens?
Go in different directions.
That's exactly right. The red light's coming off like this, the green light's coming off like that. So any questions about any of that? You're all happy about light and what it does now? So I guess stick that.
All right. Well done.